How does a ton of metal stay in the air? Spoiler, it's not magic, it's physics. And one idea changed everything. By the end, you'll see planes in a totally different way. In 9 minutes, I'll explain the 4 forces of flight, the real cause of lift, the air working around wings, both pressure and momentum effects, the lift equation engineers use every day, and why the Wright brothers' secret wasn't power, it was control. Let's go. First, the basics. Every aircraft in steady, level flight balances 4 forces. Weight, gravity pulling the plane down, lift, the upward force produced by the wings, thrust, the forward push from engines or propellers, and drag, the aerodynamic resistance slowing the plane. Fly steady, lift equal sign weight and thrust equal sign drag. That simple balance is the first thing pilots learn. Lift is an aerodynamic pressure force generated across the wing surface. People often hear Bernoulli or faster air equal sign lower pressure. That's one piece. But lift isn't just a pressure trick. Air meeting the wing is redirected downwards. Newton's laws say, if air is pushed down, something must be pushed up. Both descriptions are 2 sides of the same physics coin. Both are correct. An airplane wing is an airfoil, a specially shaped surface. As the wing slices through air, flow speeds and pressures vary above and below the wing. Above the wing, the flow often speeds up, producing lower pressure. Beneath, pressure stays higher. This pressure difference integrated across the wing surface produces net upward force, lift. At the same time, the wing deflects a column of air downward. Multiply that downward momentum change by the mass flow, and you get an upward reaction force. Aerodynamics textbooks show both views, Bernoulli's pressure picture and Newton's momentum picture, and engineers use the one that's most convenient. Engineers use a practical formula every day. Lift equal sign 1/2 x RO x V2 x SX CL. Read it as, lift scales with air density, RO, the square of speed, V2, the wing area, S, and a dimensionless lift coefficient, CL, that depends on shape and angle. The key takeaway, doubling speed roughly quadruples lift. That's why takeoff speeds are high and why wings are sized carefully. Important design concept, angle of attack, the angle between the wing's chord line and the oncoming air. Increase it too much and the smooth flow separates, turbulence grows, lift collapses, that's a stall. Pilots don't avoid steep angles because they're reckless. They manage angle of attack to keep lift safe and efficient. Pilots don't avoid steep angles because they're reckless. They manage angle of attack to keep lift safe and efficient. Now the history, many think the Wright brothers only put a more powerful engine on a frame and, ta-da, flight. Not true. The real problem before them was control. People had gliders and ideas, but they couldn't steer reliably in 3 axes, pitch, roll, and yaw. The Wrights built wind tunnel data, refined wing shapes and, crucially, invented wing warping for roll control, and paired it with a properly designed propeller. Their breakthrough was combining control, lift data, and efficient propulsion. That's why their 1903 flights at Kitty Hawk mattered. Short hops with full pilot control. Later came higher speeds and jet engines. A jet does the same job as a propeller, but by ingesting air, compressing it, burning fuel, and expelling high-speed gases to produce thrust. Modern aircraft add computer-based stability systems, fly-by-wire, composite materials, and precision design. But the 4 forces and lift fundamentals remain the same. Understanding lift and control explains everything from why small planes have big wings, to why airliners cruise so fast, to the drama of stalling and recoveries. It's also how engineers squeeze ever more efficiency out of aircraft. Less drag, higher CL when needed, better structures. If this changed how you see airplanes, hit subscribe. I'll show real wind tunnel footage, a simple lift demo you can do at home, and the Wrights' original notes in a future video. Drop a comment. What surprised you most? Bernoulli